this is an experiment on fractional distillation, okay? You are used to the process of distillation, but this is fractional distillation. So the process of distillation is different from fractional distillation. This is a fractional distillation apparatus. The former means distillation. The former has only one solvent. There's only one solvent. In the solution will be like what? Like seawater. Seawater has only water, one solvent, right? And a lot of solute dissolving in it. Well, the latter has two or more liquids with what? Different boiling point. Now we have here a special brew, Carlsberg. And of course you are not supposed to drink only those who are older than 18 years old. I'm older than 18 now. So I'm going to drink. No. Very nice taste, very good. Okay. So they have different boiling points. Now beer, this is beer, Carlsberg Special Brew, contains mainly two liquids, namely alcohol. Another name for alcohol is called ethanol. You write down, you're supposed to write down all that. Or ethyl alcohol and water. At this stage, you shouldn't be told what to write down, what to not to write down. Once I have already done that, you must write down immediately, okay? You are no more in primary 6. Boys and girls, do this. If not, you just keep quiet. You must be what we call proactive listener. Proactive means you listen actively, okay? The former has a different boiling point, or not different but lower. You see 80 is lower than 100, you see now. So alcohol has a lower boiling point of about 80 degrees Celsius, while the latter, which is water, 100 degrees Celsius. The alcohol will be distilled over before water. Alcohol will be distilled over. To distill over means it turns from a liquid here, and then it comes over as a vapor. Alright. The first fraction of distillate. What comes over is called distillate. L-A-T-E. Will be alcohol, which turns into hot vapor at about 80 degrees Celsius, while the water vapor steam will fall back along this, what we call, later I'll give you some notes, called fractionating column. It will fall back because as it goes up, it will cool, right? Then when it cools below 100 degrees centigrade, it will fall back, because this flame can bring both liquids to well over 100. This flame is about 250 to 300 degrees Celsius. Okay, so if it is 200 or 300 degrees Celsius, water will turn into steam, liquid alcohol turns into vapor. They will all come through. But as the hot vapor rise, two of the vapor rise up, water will come back, right? When it goes below 100 degrees, water will come back. Okay. And fall back into a round bottom flask. Now, right now, we will take up the round bottom flask from below here, and you'll find that this can be taken out, and then I will pour beer into this. This is beer. This is a lot of. Why is there a lot of bubbles? Can anyone tell me why beer has a lot of bubbles? Or why your aerated drink has a lot of bubbles? It has a lot of carbon dioxide as well. So it has a lot of carbon dioxide. Now, since you cannot drink, you can at least smell right now. Smelling is not drinking. Now this is beer. This is beer. Nice smell. Wow. I cannot drink, huh? Nice smell. You smell before who was drinking? Huh? Cousin was drinking. How old was he? Nice. It smells like wheat and malt. M-A-L-T. Sometimes they made up from wheat. So I'm sure Mr. John Xiao knows the smell of beer. So what I do is I'm going to shake up the carbon dioxide first because it's so much foam. Huh? And this foam, we call it the head, H-E-A-D, head of beer. When you pour into a glass, there's a head. This is called the head. Just like the top portion is called the head. So we're going to put this in. And you find that beer, if I put beer on the table, beer, although this is 8.8, which is the maximum allowable for beer, will not burn. Let's see whether beer can burn or not. Okay, beer will not burn. So let's put a flame onto this. You think the beer can burn? Let's see, yeah. This is a blowtorch. I hope that there is this. Oh. Never mind. Okay, this is a blowtorch. Then you find that if I put on here, the beer will not burn. Huh? Because it's only 8.8%, now 91.2 will burn. But if alcohol comes over first, after we will compare to see whether it will burn. So right now, we are going to fractionally distill the alcohol over first. Okay? Alright, so you notice I closed the air hole right now, so that I can have a luminous flame that I can see, right? Luminous flame is not dangerous, I can see it now. It's not dangerous, is it dangerous? It's not painful, okay? Now this is non-luminous flame. Now this is hot and dangerous in the sense that you cannot see, you better be careful. And anytime when I'm not using, you must close the air hole, it becomes luminous. Is that clear? And that is safety, yeah? So now we are going to boil off the beer. And let's see what is happening here. And as it boils off, it will begin to foam. Then as the hot vapor comes through, we will collect the hot vapor because it will be cooled by the aircon. While the temperature here is low, maybe we can switch on the aircon. Yeah. Okay. Okay. So now we have got the beer coming through. Cannot be quickly, yeah. The beer needs to warm up from room temperature to more than 100 degrees Celsius. This flame is more than 200 degrees Celsius. Okay, it's more than 200 degrees Celsius. All right, let's see what will happen as the beer comes across first. Maybe it will help this. This is double heating to speed up faster. Okay. What do you think? There's porcelain chips inside. Huh? Inside there, can you distribute that for them to have a look? One. And you can see diagrams of distillation and fractional distillation. Distillation is at the front, figure at the bottom, and then if you turn over, fractional distillation is that. Fractional distillation is that. This is a little bit different in the sense that there are no beads inside. Usually there will be beads here, but this one we wouldn't have beads. But we have a special fractionating column where you have gaps going in to cool the steam. Okay, so it's the same whether you use beads or you use gaps. Can you see the vapor is beginning to crowd the fractionating column? We call it the fractionating column. Alright, what do you think is the main reason for the porcelain chips inside? Question number 1. What do you think is the purpose of the porcelain chips? What do you think is the purpose of the porcelain chips? You'll notice that the bubbles are very small, aren't they? Okay, so the purpose of the porcelain chips is to keep the bubbles small. And when you keep the bubbles small, it will not have very big bubbles that it causes bumping. You know what I mean? If you don't have porcelain chips, there is no sharp points for the bubbles to form. So when there are sharp points inside the porcelain chips, these are actually the blue porcelain chips that you see there. It's mainly a cup. I break the cup and then I put it inside. Okay. Right. Now it's going to come through. Okay. It's going to come through. And let's see the vapor coming through. We'll have the vapor coming through in no time. Let's speed up the heating. Of course, these glasses are pretty good glasses, so it can withstand heating. So can you see it's coming through? If the procedure is set up properly, it will have to be water going in, cold water going in from here. Flood the whole, what we call Liebig condenser. If you cannot remember the word Liebig, L-I-E, Liebig. Some of you Liebig, right? Big lie and small lie. So Liebig condenser, you can remember it as a Liebig condenser. Now you find that it's coming through, and I'm going to try to get the vapor over there, but we don't have water, but it will cool by itself, and we find that it will come through like this. Now there is a thermometer here. This thermometer is just around the place where the hot vapor comes through, and when I read this, it should be around 80 degrees centigrade when alcohol first comes through. Alright, can you see now? It's coming through. It's coming through. There's also carbon dioxide coming through. Oh no, slower, slower, slower. And of course now the football season is on. And when the football season is on, your parents, your father who likes to watch football, and your uncle and their friends will be drinking a lot of beer. Go and ask, any of you know what's the favorite brand of your father's beer? Carlsberg. Wow, okay. Carlsberg. But this one is special brew. This is special brew, okay? Alright, come on, come through, come through, come through. See, we will try not to gather the foam. The foam is mainly water with bubbles of carbon dioxide. So we must control that the foam doesn't come through, only alcohol vapor comes through. Alright, Mr. John Shaw, can you go over there and try to read the thermometer reading for us? And let's see what it's going to be. What's the temperature now? Be a bit careful. Can you see? You might want to climb out on the chair and see. Yeah. What is the temperature?
I don't see anything.
You won't see anything. Do you see anything? Do you see the mercury inside? Ah, no, I don't. Oh dear. Yeah. Yeah. Of course. Anyway, I'll read. The temperature right now is about 50 something, but it's slowly climbing now. Okay, try and see again. Can see the
Yeah.
Oh yeah. Okay.
Moving to 80.
Moving to 80, I think your science teacher needs to wear a pair of spectacles. Right? Can you switch off the aircon? Okay. So the vapor, can you see the vapor coming through? There is a liquid now. Can you see it's a liquid? Can you see the liquid coming through? Can you see the liquid? The liquid here, coming through here. Although we don't have water, we are air cooling the vapor enough. Because if the boiling point is 80 degrees Celsius, our room temperature is only about 25 right now. So the alcohol, hot alcohol vapor will then condense into a liquid. Now this is pure alcohol, not water. So you notice that even though the beer is yellow, the alcohol is white. Huh? It is white right now. Can you see? Alright, so we are going to collect the alcohol, collect more and more. Okay. Alright, since we are running out of time, we will have to stop this. We'll have to stop this. And then we are going to burn. We're going to burn this alcohol. This is pure alcohol. Pure alcohol is coming through. Wow, we have got quite a lot of alcohol here. Okay, the camera can zoom into here. Yeah. Now you wouldn't want to drink 100% alcohol. It's going to burn your esophagus. It's going to burn your stomach. Okay. Now I'm going to pour this here. I'll switch off the light a little bit. And then I pour this here. Okay. And see the alcohol burn. Look for the alcohol burn. Oh, that's what your parents are drinking. Oh my gosh. Oh my gosh. They are drinking things that burn. Come on, take the camera. Alright. Take your camera. And can you see this? Can you see this? I'm going to put my hand over this. Look, my hand burns. You see the flame? No, you didn't see the flame. Yeah, okay. That is burning. Okay? Finish. Now the other thing I want to try this. is this. This is beer, okay? And we are going to burn a $10 Singapore note. This is a paper $10 Singapore note. $10 Singapore note. Okay. Real $10 Singapore note. And this time I use a special alcohol which is 70%. 70% alcohol. That is called isopropyl alcohol, 70%. And there you see, look, I dip this in alcohol and then I'm going to light this. Alright, look, take. Oh, this $10 is burning. Can you see? Yeah, let's try that again. Yeah, okay. Ready? Go. Is this $10 burning? This is burning right now. Wow. Burning $10. Fine. Yeah. Did he say yeah? Alright, thank you.